Hello friends, welcome back. We're writing a little compiler with, I hesitate to call it type inference, but it knows a little bit about types, and it doesn't do a whole lot yet, but we're getting there. We can do integers and strings and variable setting and getting. So wouldn't it be cool if we could compiles method definitions. If we could do that in this video, I think that would be pretty cool. I don't know how far we'll get. I'm not gonna make any promises. Let's just be open-ended about it and see what happens. So def foo, and foo returns the string foo, and that's it. So no arguments, nothing too fancy. Let's go compile that code and then say that it must return something like this. Okay, we're going to have two instructions for the boundaries of a method. We're going to have, let's say this type nil instruction is, should I just say def? Yeah, def is fine. And we'll give it a name. That'll be the first argument. And then here will be end def and end def. And I'll go ahead and put the name in here, make it easier to spot the boundaries of a method, and which one goes with what. And so inside of this, I suppose this will be a stir, and this will be a push stir, and this will be a string. So that's kind of what I'm going for. And right now it says unknown node defen. So we'll just go implement defen. When defen name and the args and the body. Now I don't remember if this just keeps going out. Let's go try it. If I have bar here, what do I get here? Yeah, these, I should just splat these items. Yeah, why not just encode that in the thing? Should I? No, change my mind. So we have the args, and then we have the body is here, node. So we want to instructions. I'm just going to copy this and cheat instruction new def arg is name, and then here at the end we'll do instruction.new end def arg is name. We're going to return this, something like that, and then for each node in the body we're going to call transform node like so. What happens here? Some helpful message here. Compiles method definitions. So we're calling type exclamation mark on one of our instructions. So that makes some sense. Let's go to our compiler spec and figure out which spec that is. 53. Yeah. For now, let's do this. Instruction type if, let's see, return if name is end def or name is def. Yeah. Fix me. Okay. Or to do. That gets us close. So that we're just turning off type inference for that for now. But that's not actually what we want, right? But that does get our spec passing, which is good. So let's pull up our compiler spec and let's see, what would it take to determine the type of this method, the return type, so to speak. I think the end def instruction, What is the type? Oh, yeah. Maybe it could be nil. Let's leave it nil for now. and let's see about if we were to call this method. Compiles method definitions. Yeah, so what I really want here is to be able to call foo. And what would that look like? So that instruction would probably be a send instruction in Ruby parlance. I'd be sending foo with 0 arguments. And do I need a receiver? Does that mean I need a push nil? Question mark. I mean, we're making up our own VM instructions here. Let's say this is a call, and let's go handle the call node over here. When call, and we're going to ignore the receiver for now. We're always going to assume that it's nil, and then the name of the method call. And we'll do something like this. So the instruction is a call instruction, the name, and then the extra arg is going to be 0 for now because we have no arguments yet. So we'll just return a nil there. And then return this instruction. How close does that get us? Unknown keyword extra arg. That's right, because I decided not to add the extra arg until I needed it, but we need it now. Extra arg is extra arg, and I gotta put this in all the places. Extra arg. Okay, how was that? Okay, very good, very good. So we don't know the type of the call yet. So this is not going to be nil. This is going to be stir. That's what we want it to be. We want to know that the return type of this call is a string. And to do that, we need to know the return type of the method. And so I think that means we need this to be a string. And to know that, we need to know that the method has a dependency on its return value, the last expression in the body of the method. And then the call to foo has a dependency on the method definition itself. So we need a place to store methods, I believe. How do we do that? How can we make that happen? First of all, though, it'd be let's get our test passing here. Instruction or name. Oh, this is getting kind of wordy, right? End def or call include name. Okay. There we go. Now we have a failing test, but the failing test will help us to see what we're supposed to be implementing. So that's kind of what I was going for. So this is different. It's kind of hard to see what is different here, but this one versus this one and this one versus this one. So exactly what we would expect to be missing are the types for this instruction and the type for this instruction. End def, I think could always be nil. I don't think that the type matters on this one. So I'm going to leave this pane open, and this pane can probably close for now. And then back over here. So for the def instruction, we want to add a dependency. Instruction.add dependency, and that is on the body. Let's see, return instruction. Okay. And the return instruction, body instructions, and we'll do a map, and then the return instruction is the last of the body instructions. Okay. I think I'm just making this up as I go. What could go wrong? Add dependency on the return instruction. And you can see right away we went from stir nil here to stir. So you already know the return type of the method, so that's cool. And then now we need to know how to do this for a call. So this is where things get a little bit more interesting. We need to store Methods, sort of like we were storing variables. So down here, let's do set method name instruction, and we'll do methods name. We only ever want a single method, so we'll do it like this, and we'll say raise, let's see, if there's already something at that, then we'll raise a type error. And I know I'm writing code without a failing spec, but how bad should I feel about it? Just say to do. Okay, so we're gonna set it here, set method. Where did we do set var here? We did it right before set method name instruction. This is going to be a very procedural language. Definitely at first, we're just going to have one global set of methods and really no objects. No implicit conversion of symbol into integer. Okay, so methods doesn't exist. I'm not sure what that error is actually. 96. Methods must be something. Def methods. Oh, right, that's a built-in Ruby thing. Okay, let's say our methods or method definitions. Yeah, it's a little wordy, but it's not to be mixed up with the Ruby thing called methods. So this would be, I suppose, just a global. Yeah, there's no scope information. So let's just say methods is like an instance variable here, and then we can just do methods like this. Methods name instruction. Cool, we're back to a failing test for the right reason. I say that a lot. Failing test for the right reason. And then, so we have the method. When it's defined, we set it in this hash. And then when we call a method, we want to add a dependency on at methods name. Or do we? What if the method is not defined yet? I think that's okay. Or that's not okay, actually. I'm in my language, I'm making it up. I'm going to say that the method has to already exist. So I'm going to change that to a fetch, which will raise an ugly error if that method does not already exist. Okay, so we add a dependency to the call on the method, and that didn't make the test pass. But why not? Why not? Is it because over in instruction, I'm actually, yeah. How is this working? How did this one start working? This def. I don't actually know. It's a little bit scary. So stir. Good. Type stir. What is changed here? Push stir. Wait, what? Did we not? We did something wrong. Because we had. Oh, this was always wrong. Oh, I'm pushing it. Oh, I'm pushing them out of order. Okay. Yeah. Earlier when I said that these were matching, I was actually looking at the wrong thing. So this one, def, needs to go over to the other side. How did I get that? How did this happen? Oh, that's what happened. We called transform on the body before we appended the instruction. Okay, very good. So I think if I do this up here, all the tests are passing. Yes. Oh, that's so cool. Very good. Let's add all this to the index in case I screw something up. So we're going to say return Instructions with no type. Instructions with no type is equal to that. And yeah, let's put this on multiple lines. Okay, so if you ever see an indef, it's always going to have a nil type. And then, yeah, that's a little bit cleaner. Very good. What else can we do in this video? 15 minutes. Okay, definitely a little bit over my limit. I think that's good. I think that's good. We have methods. We can call the method. Let's see what happens if we call the method more than once. I assume everything will just work. So this would all just be a stir as well. Okay, great. What if this is an integer? Well, let's do a new method. Def bar 1 in and foo and bar. Okay, so let's see if we can go ahead and create the proper stuff here. Int proper instructions and def bar, and then we'll call bar, and this is an int. I think I got all the types right except this one and this one. Stir nil, int nil, stir int. And all the tests still pass. Very good. Okay, great. For this video, that is all I needed. Day 6. Oh, that is not what I meant to do. Okay, very cool. Well, thanks for hanging out. I hope that was a little bit interesting. I hope you can start to see what's coming together here. And this whole thing might crash and burn and I might throw it all away. But at least I had fun, and I hope that you're having fun hanging out. And I guess I'll see you in the next video. Bye.